If you notice back in example 8, what happened here is you were given a principal and interest rate and time, and the more often the interest is compounded, then greater your balance can be. So if you continuously compound something, that's going to be a larger balance than if you just compound it quarterly. Same thing if you were to compound something monthly, it would be larger. Weekly, it would be larger than monthly, and on and on and on. Anytime you compound something continuously, that's going to be greater than compounding it so many times a year. So the largest you could ever get something to be for a balance would be to compound it continuously throughout the year. Here in example 9, what we're going to do is we're going to have a little bit of radioactive decay. And I know you guys all enjoy this radioactive decay. I know it's a little different than decay on your teeth, but that's a good thing. So hopefully you learned about this a little bit in chemistry before. But what we're going to do is we're going to let Q represent the mass in grams of radium, which is 226 part A, whose half-life is 1,620 years, and the mass of radium present after T years is given by this equation. Q equals 16 to the power of times 1/2 to the power of T divided by 1620. So the first thing we need to figure out is what is our initial mass. Well, this value here in the beginning, this is always your initial amount. So for your initial mass, that is going to end up in B, 16. Well, 16 what? It's going to end up in B, 16 grams. Second thing you have to do is just evaluate this after 1,000 years. So if we're going to plug in, figure out what our quantity is. Now if it's getting smaller, we should get a value that is less than 16. At least that's your goal. If you have decay, something is getting smaller. So after 1,000 years, you're going to take 1,000 divided by 1620. So you just go ahead and evaluate this problem. So Q equals, don't take 16 times 1/2, make that an 8. This is 16 times 1/2 to the power of, I got a little crazy. So 1,000 divided by 1620, 1,000 divided by 1620 gives you 0.6173. So we're going to write that in for our power here, 0.6173, and we go ahead and just plug this into our calculator, like so. So we'll say 16, parenthesis, 1 divided by 2, or you put a 0.5 to the power of 0.6173. So your final solution, you should get a 10.4302 grams. 10.4302 grams. That's how much is left over at the end.